Okay, we're going to start the concept of solving differential equations. Those of you moving on to engineering, math, any very sciencey type of subject, you'll probably be taking a full course of differential equations in college, and that one gets pretty intimidating. This little subject will feel intimidating at first, but then you're going to realize that it's not so bad, and you'll find that if you run across one of these questions on an AP test, they give tons of partial credit. So much partial credit that points start falling from the sky, and you're actually required to wear a helmet during this for your safety. All right, so as we go through here, we're going to focus on following these steps. And the steps: separation of variables, you don't know what that is; antiderivative, you do know what that is; and solving for c and y are both going to be exercises of good old algebra. You have to be sure to follow these steps, because the way an AP rubric works, if you're not following those steps, they may literally not give you points, even if you get a correct answer. So pay attention to those steps. Up here is our original problem, which doesn't necessarily look like a problem to you, but it is. This right here is a differential equation. It's a differential equation because it has a derivative in it, and it's an equation. Equal signs means equation. So a differential equation is just an equation with a derivative in it. To you, this might look like a first derivative, and you're not really wrong. And this thing right here is called an initial condition. And basically what we're looking at is there is some function out there in the world that gives birth to this derivative, and that function has this as a point, or in other words, that function goes through x equals 2, y equals -4. So let's find that function. The first step is separation of variables. That's new to you, but watch how easy it is. A y wants to hang out with a dy. A dx and a 2x want to hang out together. So all I've really done here is I've multiplied both sides by y so that it cancels over here, and there it is over there now. And I multiply each side by dx so that the dx's cancel, and I get 2x dx. Just a simple algebra move, but this is what we've just seen right there, is separation of variables. Once you do separation of variables, you need an antiderivative. And the antiderivative of a y is a 1/2 y squared. The antiderivative of a 2x is an x squared. And you might say, well, what happened to my dy and dx? Well, those are derivative symbols. So when we do an antiderivative, you can kind of justify it by an antiderivative would get rid of a derivative symbol. An antiderivative would get rid of a derivative symbol. If you don't like that, think about it this way. When you have an antiderivative of x squared, if you're going to check it, you take its derivative. So go back upstream to get 2x as taking its derivative. And you would say, I just did 2x, and I did the derivative of an x term. The derivative of this is y, and I just did the derivative of a y term. However you want to justify it, the dy and the dx, they will get out of the picture when we go to that step. Don't forget your plus c on your antiderivatives. This plus c is going to make you a little bit angry here. C is just a number. So if I take this c and combine it with this c, I've done this in the algebra world. Well, a number minus another number is still just a number. So I still have a c here. Because remember, this could have been, say, a 5, and this could have been a 12. When I move that 5 over, this is now a 7. We just called him c. Everywhere we go, we call that c. So it goes against your instinct, but c minus c is c. All right. I have now done the antiderivatives. I've done the separation of variables. I need to either solve for c or solve for y. And in this case, I'm going to solve for c, but after we're done with this problem, I'll show what happens if we reverse the order. In this equation, I now go back and I say, they told us the initial condition was 2 comma negative 4, so I plug in the 2 and the negative 4 into that equation. And by doing so, I'm left with just a c, and I solve for c. So now I know c is 4. If I went back up to this equation, I can replace that c with a 4, which is what I did right there. Okay, I've adjusted the paper, but we've solved for c, and according to those 4 steps on top, after you solve for c, you have to solve for y. So I take that equation, and now I break out my algebra skills, and I get y by itself. So the first thing I do is I multiply everything by 2. Technically speaking, I've multiplied this side by 2 and that side by 2. From here to here, I've square rooted the left side, I've square rooted the right side, and your algebra teacher taught you that when you square root in an equation, you use this plus minus. So you think you'd be done here, and if you got that far, you would get almost all the points on an AP test, and that would be a really good job. However, they told us from the initial condition that f of 2 equals negative 4. Or in other words, when I plug in a 2, I better get back a negative 4. So if I plugged a 2 into here, 2 squared is 4. 4 times 2 is 8. 8 plus 8 is 16. I get a plus or minus square root of 16. But I'm supposed to get a negative 4. So the plus or minus square root of 16 has to be just turned into a minus square root of 16, which is really the negative 4. Long story short, because of this initial condition, this final answer is more precise and actually accurate by just choosing the minus. And a little bit of a vocabulary thing here. What we have just found, our answer to our differential equation, is called the particular solution to that differential equation. This is an equation that has that for a derivative. I know that doesn't make sense to you right now, but it also goes through the point 2 comma negative 4. There's your answer. But let's go back up here. Let's see, I'm going to rearrange the paper. Okay, I've rearranged the paper, and if you take a look, as we were going through these steps, when I got to here, I decided to solve for c, and that's what we did. But I could solve for y first. So if I want to, and I'm going to, we're going to take that and solve for y before we solve for c. So there's that very same equation. We're just going a different way now. Multiply both sides by 2. So now there's something very, very important happening here. If I multiply that side by 2 and that side by 2, 2 times a 1/2, that's a 1y squared. Then I distribute this in to both sides, to both parts. 2 times x squared is 2x squared. And it doesn't look like I've distributed to the c, but I have. 2 times a number is still just a number. I know that drives you crazy, just like c minus c equals c drives you crazy. It's still a constant. Now breaking out my algebra, I square root both sides, and I still haven't solved for c. Remember, now I've solved for y, so I've done that one first. So what I do is I plug in my x comma y initial condition. There's my y, there's my x. That allows C to be the only thing we don't know in there, so I can go ahead now and solve for C. All algebra solving for C, I get a C equals 8, which seems wrong because we got C equals 4 over here. It's actually right, we're just following a different path. So now I take that C equals 8, I go back into my Y equals and I replace it, and I have that same plus minus dilemma. I need to use the minus, and I end up with the same answer here as I did here. Different path, same answer. Okay, we're going to take these steps and do one more problem. Okay, a brand new problem. It's a differential equation because it's an equation that has a derivative symbol in it. They give us an initial condition. They say the equation that gave birth to this, which is f of x, it travels through the point 0, 3. So I know later on x is 0, y is 3. And we need to find the particular solution, f of x. We're going to follow these steps. Do these two in whatever order you think is easiest. So I'll unveil some steps here. The very first step is separation of variables. This y wants to hang out with that. This dx and 2x want to hang out together. So by algebra, the y and the dx, they move. It's a little bit of racket going on here, huh? So I've done the separation of variables. Now I do the antiderivative. This is a y in the denominator with an exponent of 1, which makes the antiderivative natural log. And I have to put the absolute value bars there if I want to be totally precise, because natural log will only accept positive y values. This is a positive y value, so I think we're okay if we skip it. Antiderivative, I have the plus c on both sides. Technically, you could just put a plus c over here and just say that c is already combined with that, and that would be okay. Move the c over. And now, we have to break out some pretty serious algebra. To kill a natural log, I have to do e to both sides. E to the left side, e to the entire right side. Be careful because you'll be tempted to write this. And that is not true. This, naughty. And you will end up with the wrong answer. What I did to the whole left side, I do to the entire right side. Now at this point, I have some very easy algebra property that you may have forgotten about. Remember, if you had x squared times x to the 5th, you got x to the 7th, and technically what you were doing is x to the 2 plus 5. Well, we're going to do that in reverse. If I had e to two things that were added together, then I could rewrite that to look like this. All right, so if e to the something times e to the something was what I had, I would add the exponents. So I've done this algebra property in reverse. And in this case, the e to the natural log of y, the e and the natural log are inverse operations, so we just get the y. All right, pretty straightforward and tricky at the same time algebra property there. And e to the c is e to a number, which is just a number, so I can write it like that. So that's a coefficient, and most people feel comfortable with their coefficient in front of the term, so I would rewrite it with the c out in front. You're an American. You deserve your coefficients out in front. All right, so now we have solved for y, So I've actually done this one before this one. Now I have to solve for C. Here I've solved for y. I plug in an x equals 0, y equals 3, because that was in the initial condition. And lucky for us, 0 squared is still 0, which makes that a 1. That's really easy to solve for c. C equals 3. So I take my c equals 3, plug it back up there, and now I have the particular solution. That's my final answer. All right, differential equations. You must follow this procedure. If you do, it's just a tangled mess of calculus antiderivatives and some good old-fashioned algebra.